Michio Kaku, a leading figure in modern science, has once again shocked the world with his stance on the universe. According to Kaku, recent discoveries made by the James Webb Space Telescope, JWST, including the detection of 3 very old galaxies the size of the Milky Way, challenge the long-held beliefs in traditional cosmology. Kaku argues that these findings are incompatible with the concept that galaxies could not have existed in the early universe, especially within the first few billion years after the Big Bang. This has led Kaku to believe that there are fundamental flaws in the way we understand the origin and evolution of the universe. Kaku is not just a physicist, he is a gifted communicator who simplifies complex scientific ideas like no other. Though he has not won a Nobel Prize or made groundbreaking discoveries, his ability to explain complicated concepts has made him a best-selling author and one of the most important science communicators of modern times. When he asserts that the Big Bang theory is outdated, Kaku has valid reasons. Even before the JWST's groundbreaking discoveries, Kaku knew that existing cosmological models were flawed. According to him, the textbooks are outdated, and the scientific community has been clinging to an untenable worldview since the mid-1990s, when early evidence started emerging that contradicted the idea of the expanding universe. The JWST's 2023 revelations only add to the growing body of evidence that undermines the old theories. While many had hoped that the telescope would confirm the Big Bang and the expansion of the universe, it instead exposed profound anomalies. The oldest galaxies detected by the JWST appear so ancient that their existence challenges the 13.8 billion-year age of the universe as proposed by traditional cosmology. This discovery has raised questions about the age and origin of the universe, especially considering that none of the methods used to determine the universe's age have been confirmed. The revelation that these galaxies are so old raises even more questions. How could galaxies of such complexity and structure have formed so early in the universe's history? Kaku believes that the 13.8 billion-year-old universe model is a fallacy, and scientists who continue to cling to this outdated theory are living in denial. The idea that the universe has been expanding for 13.8 billion years, starting with the Big Bang, is rooted in early observations by astronomer Edwin Hubble, who found that galaxies appeared to be moving away from each other. This led to the hypothesis of an expanding universe, which has been the cornerstone of our understanding for nearly a century. However, Kaku points out that while Hubble's observations were groundbreaking at the time, the assumption that galaxies are expanding in the manner previously described is now being called into question. However, as early as the mid-1990s there were signs that this expansion theory might be incorrect. By the late 1990s, evidence began to emerge suggesting that Hubble's observations might have been flawed. Despite this, many researchers continued to adhere to the old model. Now, with the JWST's discovery of galaxies older than the universe itself, this theory is being questioned. These revelations suggest that the universe's timeline may be more complicated than we have been led to believe. Additionally, the JWST has highlighted a crucial flaw in the expansion model: measurement. Discrepancies known as the Hubble tension. Different methods of measuring the expansion of the universe yield inconsistent results, further questioning the validity of the theory. Yet, despite these inconsistencies, many researchers continue to insist that the expansion theory is a proven fact, ignoring the mounting evidence that suggests otherwise. Kaku is critical of this refusal to confront the facts. He notes that no one has ever provided solid proof for the Big Bang theory or the age of the universe. Before the launch of the JWST, no telescope had even come close to observing the earliest stages of the universe or the formation of the first stars. These ideas were all based on calculations and theoretical models, not real observations. Now, with the JWST revealing galaxies as developed as the Milky Way from 13.6 billion years ago, Kaku is left questioning the plausibility of the old theories. How could such advanced galaxies have formed so early in the universe's history, when researchers believed the process would have taken billions of years? This discovery is a significant challenge to our understanding of galaxy formation. It suggests that galaxies may have formed much more rapidly than previously thought, or perhaps that our models of how galaxies evolve are fundamentally flawed. In light of these discoveries, some researchers are attempting to revise the current models by suggesting that galaxies may have formed much faster than previously thought. However, Kaku remains skeptical. He argues that no matter how much research is done, the facts remain unchanged. We do not truly know how or when matter was created, or how old the universe really is. The dark matter and dark energy theories that currently make up most of the lambda CDM model have never been proven, and Kaku believes that these constructs might be flawed. The discovery of these ancient galaxies provides an opportunity to reassess some of the key assumptions that underlie our current understanding of the universe. While Kaku acknowledges that many researchers continue to hold on to these outdated theories, he is not dogmatic about the truth. He has long advocated for an open-minded approach to science and cautioned against the arrogance of researchers who present theories as absolute truths. Kaku believes that we may never fully understand the universe, as its complexities could defy our current methods of observation and calculation. He suggests that quantum physics, his area of expertise, offers an alternative view of the universe, one that may eventually lead to a unified theory. However, he is realistic about the challenges of reconciling quantum physics with traditional cosmology, as many of the results in quantum physics do not align with the lambda CDM model. Kaku is a proponent of string theory, which proposes that our reality is composed of more than just the four known dimensions. While string theory has its flaws, Kaku remains hopeful that it could one day provide a more complete understanding of the universe. String theory has yet to be proven, and it remains a speculative framework, but it could potentially open the door to new ways of thinking about the universe's structure and origin. If string theory, or another unifying theory of physics, is eventually proven correct, it could change our entire understanding of reality and provide answers to some of the most fundamental questions about existence. Until then, Kaku believes that we are left with fragments of the truth and that our knowledge of the universe will remain incomplete. Kaku is open to the idea that we may never fully decode the mysteries of the cosmos, and he embraces the uncertainty, viewing it as a sign of the limitless possibilities that the universe holds. As he continues to explore and communicate the wonders of science, Kaku reminds us that the quest for knowledge is an ongoing journey, and we are only at the beginning. Ignorance, he suggests, is not a flaw, but a reflection of how much we still have to discover. Kaku's attitude toward the mysteries of the universe is both humble and hopeful. He recognizes the limits of current science, but remains optimistic about the potential for future discoveries. He calls for a more open-minded approach, one that is willing to question assumptions and embrace new possibilities. As new technologies, like the JWST, continue to provide us with glimpses of the cosmos that were previously unimaginable, Kaku believes that we are on the cusp of a new era of scientific discovery, one that may ultimately redefine our place in the universe.